Day class. It's Sir Capistrana again, and welcome back to another discussion for our Physics 1, General Physics. And for today, we'll be looking into another topic. As you may see here, I actually skipped some of our discussion regarding kinematics. And by kinematics, as you may have remembered, kinematics are properties or quantities that are used to describe an object in motion. And for today, we'll be looking into another topic, which is actually called dynamics, which are actually the relationship of motion with the forces that causes it. And in that, uh, we actually skipped some of the three-dimensional kinematics, wherein we have discussions regarding uniform circular motions, uh, and also some of other problems regarding kinematics, wherein we also miss some of uh, the discussions. But I think Newton's law of motion is more important. And, I know that I have bombarded you with a lot of equations and a lot of problems regarding kinematics. So in here, we will be looking into the causes of that kinematics or the causes of that movements, wherein we will be talking about forces. And those forces are actually discussed under this classical mechanics, or what we call Newton's law of motion. So in here, class, by Newton's law, we already discussed the kinematics. And as I stated in our introduction or introduction of this video, this is actually the language and mathematics, lang and math, that describes motion. By language and mathematics that describe motions, these are actually those quantities that we already discussed, wherein we talked about displacement, we talked about position, we talked about velocity and acceleration. And in our discussions of Newton's laws, ay marami nga kasi yan, by Newton's law, we'll be talking about dynamics, wherein these are the relationship of the motion itself and the forces that causes it. So as you may have remembered or you may have noticed in our discussion earlier in this course, in our discussion of kinematics, we just described the magnitude and direction of the movement of the object, but we haven't talked about the application of force or yung relationship ng force dun sa motion natin. So in that, we in that dynamics is actually called Newton's law of motion nowadays. Although Newton's law, if you don't know who is Newton, Sir Isaac Newton, actually provided us the foundation of what we call classical mathematics or classical mechanics, or also called the Newtonian mechanics. And in this mechanics, we will be actually familiarizing ourselves on motions and also dynamics. Okay? So, kung maalala nyo dun sa ating Foundation Day, one of the questions in our quiz B is actually this: how we can state Newton's laws or Newton law or state Newton law. And as you may have remembered, the only answer that is provided us by the quizmaster is a body that is in motion or at rest will remain at motion until an outside force is acted on it. But actually, that is just one of the laws that is provided or that is stated, but there are actually three Newton laws. So, madali namang i-discuss or madaling banggitin yung Newton's law. Kasi kung iisipin natin, when we are talking about motion, araw-araw naman tayong gumagalaw, araw-araw tayong nagli-lift ng object, nagpo-push ng object, nagpo-pull ng object. So, along the way, meron na tayong common notion or common sense regarding this idea of motion and forces. And by forces, those are the quantities or physical notion kung ano ba yung nagko-cause ng tinatawag nating motion. But for as I may have remembered, kahit ako, I have troubles on how I develop this notion of or this common sense regarding Newton's law. So in that, let's first describe forces itself. So in that, nandito na to. Napaaga yung slide na to. But in any case, we'll be talking about forces and interaction. So para lang masimplify natin. Yung sabi nga natin, yung first law that is on ang tawag dito? No net force, tinatawag natin, or yung sinatawag natin inertia. By inertia, it is the tendency of an object to remain at rest or in motion and until or unless an object or a force is acted on it. We also have our second law, wherein the second law states that we have there an inertial property of an object wherein kapag meron tayong, if we have net force, it just means that we will be having acceleration. The acceleration, it doesn't mean na lagi yung pa-increase. It can also be decreasing. And lastly, we have the third law, which states that for every action, there is an opposite reaction. Okay? So those are the simplifications of Newton's law. Ano na lang, disregard na lang yung quotation mark, it should be an apostrophe. Okay? And that we'll be talking about forces and interaction. So there are actually a notion regarding forces, and by forces, in our everyday language, we just say that this is the push or uh, pull. Force is just push or pull. So sinasabi natin, kapag sinabi nating force, yan ay tulak or hila lang. And in that, actually, we will be having a better definition regarding that. And by that better definition, force is actually an interaction between two bodies or between a body and its environment. So meaning to say, hindi lang siya basta push and pull. So, or push or pull. So, sabihin lang natin, it is an interaction between two bodies or between a body and its environment. Okay? So that is actually a better description or definition of our force. Meaning to say, ang sinasabi lang natin dito, by interaction of two bodies, pwede kasi yung, alimbawa, pwedeng maging push and pull. Halimbawa, magtutulak kayo ng cabinet. So, our two bodies there will be you or your hand and the cabinet itself. So if you are to push the cabinet, you will be applying force into it, and that application of application is actually what we call that interaction. So, ano naman yung sinasabi nating environment? We actually encountered this interaction between a body and its environment in our past activity regarding the Galileo drop experiment. As you may have remembered, if you, in the latter part of the activity, I asked you to drop two pieces of paper. One is crumpled, one is not. And in that portion of the experiment, you have may have noticed that uh, the fall of the paper that is not crumpled actually is lower. So, ano ba yung nangyari doon? Yung paper na yon ay nag-interact sa kanyang environment, which is yung air. So, that air actually slows down the the the, the fall of that paper, meaning the air actually applies force towards the paper. So we have there a body, which is the paper, and and the environment, which is air. Pero pwede rin natin yung i-consider as body kasi ang air, as you may have remembered in our discussion, is actually matter. So we have there many bodies. Okay. So because the air is actually interacting with a lot of molecules or air molecules. Okay? So, in here, we actually have different types of forces dahil dyan sa definition natin yan. Okay? And for those forces, these are the common types of forces. We first have what we call the normal force. By normal force, this is actually the force wherein if an object uh, uh, rests on the surface or pushes on the surface exert a push that is directed perpendicular to the surface. So, ibig sabihin lang, kung meron kang surface and meron kang, let's say, box, okay? Yung box ko hindi siya pantay. So, as you may notice here, the box is actually pushing on the surface. Bakit siya pushing on the surface? Kasi alam natin that it has a downward force. Okay? And in that, the surface actually exerts the same force or a force that is perpendicular to the surface. So kung ito yung surface natin, okay? So we have there a force that is actually perpendicular to the surface. And we actually write that force as a vector. Okay? Paano kung sir kung inclined yung surface? Sabi nila. So if you have here an object that is on an inclined surface, paano yung normal force natin? So the normal force will actually be that in that direction. So perpendicular dun sa surface natin. So that will be our normal force. And by normal force, ulitin ko lang ulit, it is the force it is the force that is exerted by the surface that is perpendicular to the surface. Okay? So that is our normal force. Okay? So for another common type of forces, we have here our friction force. Siguro naman, familiar kayo rito sa friction force. And by friction force, in addition to the normal force, a surface may exert a frictional force on an object directed parallel to the surface. So, same na force na ina-exert ng surface, but for this one, if you have a box here, and you have here your surface, baliktad yung sinabi ko. If you have here a box and this resting or moving on a surface, as we mentioned earlier, we have there our normal force, okay? And that normal force is actually perpendicular to our surface, and our frictional force is actually parallel to our surface. Okay? So, paano yung movement? Sa nakalagay dito, vector quantity yung force natin. Friction force is actually opposite the the movement. It is opposite or opposes the movement of an object. Meaning to say, if we have here a movement, the movement of an object, let's mark it as FA, yung opposite yung magiging frictional force natin. So kung nalipat yung movement ng object dito sa kabilang side, yung frictional force natin will be on the other side. So we have there our friction force. Burahin ko lang yung applied force para lang malino tayo. So it is still on exerted by the surface to the object, to the body. And it is directed parallel to the surface. Okay? So those are two of our forces. Meron na tayong normal force and friction force. And also, we have here what we call our tension force. Familiar din kayo dito? So, paano ba nangyayari yung tension force? By tension force, if you have here an object that is sitting on a surface, if you have here, halimbawa, meron kang rope, syempre, dito yung kamay mo, dito mo siya hinihila. Okay? So, if you have here your rope that is attached to our object, our tension force is actually on the direction, nandun din siya sa direction ng ating pull or ng ating hila. So, nabura ko siya, ano. So, that will be our tension force. We can write that as capital T with vector quantity there. So, nakadepende yan, or for our tension force, we actually have here a vector quantity wherein nakadepende sa kung ano yung angle ng rope mo. Kasi as you may have remembered, we will have here an X and Y quantity there wherein we will have here our TX and our TY. So that will be our tension force. And by tension force, it is actually the pulling force uh, that is exerted on an object by a rope, a cord, or kung ano man pwede nating ipamila. Pwede rin yung spring or kung ano man. Okay? Sulat lang natin. It is a pulling force exerted by exerted on a body by a rope, cord, or kung ano mang pwede natin ipamila. So that is our tension force. Okay? So, as you may see here, halos pare-parehas tong mga ito. Itong halos lang naman yung normal force, yung friction force, and tension force. And all of this are actually what we call contact force. Okay? So, by contact force, ito yung mga forces natin na meron tayong direct na contact regarding dun sa ano, or we have direct contacts between two bodies. By direct contact between two bodies, as you may see here, for normal force, we need to have a surface. For friction force, we need to have a surface and a body. And for a tension force, we will have there our rope and the body. So meaning to say, there is a direct contact between those bodies or environment. So in here, we actually have here one example of what we call long range forces. And by long range forces, iisa lang ito dito sa example ko. Kasi maraming ibang long range forces though hindi ko siya i-include dito. And that long range force is what we call the weight. Weight. And by weight, as you may have remembered, this is actually the pull of gravity on an object. It is long range because it can also act on a distance. Okay? So, if we have there an object without any surface, our force will actually be acted downwards. So, that is our weight. So baka mamaya naman nagtataka kayo, Sir, di ba may weight din naman yung sa normal force? May weight din naman yung sa friction at saka rin sa tension force. But as we may encounter uh, maya-maya or depending on the pace of our discussion, we will be discussing that our weight once the object is in on a surface is actually sometimes equal to our net force. So, nangyayari kapag flat yung ano or horizontal yung ano natin, weight is actually equal to our net force. And kapag naman inclined, parang ganun lang din. Pero ayun, papansin nyo minsan mas lumiliit yung weight natin due to that inclined. And also, present din yung dito and dito. But of all these forces, as you may see here, weight can still exist kahit wala yung surface. Okay? So that is why it is categorized as a long-range force. So, by definition, long-range forces can even act even if the bodies are separated by empty spaces. So meaning to say, kahit na isipin nyo yung sun at earth, there is still a weight. May weight pa rin yung earth natin kahit na uh, malayo siya ron sa pwede nating reference point which is the sun. Okay? Okay. As you may notice here, class, dun sa bawat notation na ginamit ko ng ating common types of forces, meron tayong arrow na nilalagay sa ibabaw ng mga ano natin, ng mga notations natin. Ang isa lang ang ibig sabihin yan. So, kung meron tayong mga arrows sa notations natin yan, ang ibig lang sabihin yan, force is actually may be considered as a vector. So, by force considered as a vector, isa lang ang ibig sabihin yan. So, if we consider to be vector to be a force, kailangan meron lang tayo magnitude and also uh, we have direction. So, yun lang naman yung definition natin ng vector. And to describe a force vector, we need to describe the direction in which as well as its magnitude. The wherein the magnitude is actually the quantity described by how much or how hard the forces pushes or pulls. So the SI unit for our force is actually Newton. Siyempre, si Newton yung gumawa eh. Or it is abbreviated using the capital letter N. So hopefully walang malilito sa inyo sa stat natin at dito. So to be exact, Newton is actually uh, ano nga bang value ng Newton? Wait lang. It is Newton is actually equal to 1 kilogram of mass per kilogram mass. 1 kilogram mass second square over meters. Sulat ko na lang na ganito. 1 kilogram mass per 1 meter per second square of movement. yun yung ating definition ng Newton. And by typical forces, kung isipin natin force as a vector, we actually have here some examples wherein halimbawa yung gravitational pull ng sun's gravitational pull force na lang. Yung sabihing pull on Earth is 3.5 times 10 raised to 22 newtons. So, ibig sabihin lang yan, yung gravitational force ng sun sa Earth ay actually 3.5 times 10 raised to 22 kilograms per 1 meter per second square. So, mali ito. Mhm. Yun. So, yan. So, it should be per 1 meter per second square. Yan. So, yan yung ating Newton. So, ibig sabihin lang yan, so, ang gravitational force ng Sun sa Earth ay 3.5 times 10 raised to 22 kilograms per meters per second square. So, yan yung ating sun's gravitational pull. And dun tayo sa medyo related. Let's hear weight ng apple. See, weight being a force. Dahil Newton nga, di ba? So this is actually 1 Newton. Okay. So by 1 Newton, the weight of the apple actually has a force of 1 kilogram of mass per meter second square. So yun yung ating vector, yung ating unit ng force. And force being a vector, isa lang ang ibig sabihin yan. Magkakaroon tayo ng tinatawag nating position of forces. Pero bago yun, kung iisipin natin, kung halimbawa, meron tayong tension force. Kung sa tension force natin, we are pulling a box towards this direction using a cord, which is actually, halimbawa, sabihin natin 30 degrees. Yung angle ng ating rope via the normal, and we are actually applying 10 newtons. Okay, so force being a quantity, ang ibig lang sabihin niyan, our force is actually 10 newtons per 10 newtons on 30 degrees north of east. So, and force being a vector, isa lang ibig sabihin yan. We will have there an x component of that force and a y component of that force. And just like our past discussion regarding this, we will actually have that force which is, ayun, andito yung ating fx, and we have a force which is towards this direction which is our fy. Okay? So, paano natin i-compute yung mga yun? Same nung sa ginagawa natin last time dun sa ating projectile motion wherein our fx will be simply just 10 newtons, multiply mo lang yan, times the cosine nung ating degrees, which is 30. So that will be our fx. Same for our fy, ganun lang din gagawin natin. We will have here 10 newtons multiplied to the sine of 30 degrees. So you will have there your x component and the y component. So meaning to say, in here, we can actually have there our f and y component. So anong ibig sabihin lang nito? So instead na yung itong pool na ito ang gagamitin natin, we can actually have the same motion or the same force that is applied to the rope, application ng rope towards dun sa object, kung kukunin natin, kung iaangat natin or hihilahin natin siya pataas by this degree and hihilahin natin siya papunta rito sa kanan by this magnitude. So, ibig sabihin lang yan kung kukunin natin yung 10 cosine of 30, try natin. Calculator. Calculator. So, we have there 10 times cosine, ay teka, lagay ko muna yung 30 times 30 cosine. So we'll have there, so we'll have there 8.66 newtons para dito sa x direction. Okay? And for the y direction, we will have here 10 times 30 sine. Okay? So we'll have there 8.66 newtons din para dun sa ating y direction. Okay? So that is our x and y components. So meaning to say, kung gusto natin ng the same force or yung same force na applied dun sa 30 degrees na yan, using 10 newtons, we can actually apply 8.66 newtons pataas and 8.66 newtons papunta sa kanan. So, that is our vector. And in that, we will be looking into the superposition of forces. And by superposition of forces, we will be just considering different vectors or different force vectors para ma-compute yung resultant natin. Same with our discussion dati. So, using the same example kanina, dun sa paghila. Okay? So, kumbaga, kung merong kang isang box, halimbawa, tapos yung box na yan, merong kang dalawang tali na kinabit. So, lagyan natin ng surface. Baka sabihin na lumulutang lang yung box natin. So, let's say you have there your first force or yung unang hila mo, or first push or kung anumang force ito. Let's say we have here our F1 and we have here our F2, another pull natin. So, mangyayari lang dito ay kung kukunin natin yung components na yan or gagamitin natin yung components na yan para makuha yung overall na force, for the superposition of forces, all we need to do is masyadong magulo ito. Teka, ulitin ka. Again, we have their force na nandito. Horizontal na lang dito. Para madali-dali tingnan. Okay? So this will be our force 1 and force 2. We will actually have a resultant force na magiging ganyan wherein this will be our R or yung resultant force natin. So, pwede natin gawin din yung ginagawa natin dun sa addition ng vectors natin para doon sa ating dun sa computations natin. So, in general, we can actually just write the vector sum of these products wherein we will have there our vector sum is actually our resultant is actually just equal to our F1 or the vector quantity F1 plus F2. Pero alam naman natin na hindi lang to basta addition. Ano? So, in any case, we will be getting the x components and y components of that forces to better understand kung ano paano mag-work tong superposition. But in general, if we are talking about this superposition of forces, we just say here that any number of forces applied to a point on a body have the same effect as a single force equal to the vector sums of the forces. So, We just write that. Any number of forces applied to a point has similar effect. So, basahin ko lang ulit. So, any number of forces applied to a point has similar effect to a single force equal to the vector sum of the forces. So, ibig lang sabihin yan, hindi mo kailangan na sobrang dami ng origins or directions ng points na pwede mong gamitin kasi you can actually have a similar effect using a single force which is equal to the vector sums of the forces. And as you may have remembered dun sa example natin kanina, if we actually separated the x components of, and the y components of that 10 Newton force on a 30-degree angle, kung iisipin mo, you will be using 8.66 newtons upward and 8.66 newtons forward na kung iisipin mo, parang mas malaki ang gagamitin mong force in comparison na gamitin mo na lang yung vector sum nila. So in that effect, this is what we call the superposition of forces. So in here, we will be actually revisiting our vectors wherein yan, ganun pa rin, we'll be still be using this formula wherein in general, our resultant force or the vector sum of our forces is actually equal to our F1 or the vector of force vector F1 plus force vector F2 up to our Fn kung gaano man karami yung forces na inad natin but it's just equal to the summation of all that forces or vector forces. Okay? So, in here, when we say about the vector sums, hindi naman yan basta ganyan lang. Ang alam natin, we need to account for all the x components of our resultant, which is just the summation of all uh, x components of the forces, plus, and also we will be looking into our Ry, or the resultant forces of y components, which are just the summation of all the forces in the y, tulad ng ginawa natin ng mga past activities natin, and to get the overall uh, vector sum of those forces, we just need to get the square root of that Rx square plus yung ating square ng Rxy. So, similar dun sa approach na pinaggagawa natin dati na for the superpositions, you just need to get the x and the y components. Pag nakuha mo na yung x and y components ng forces natin, what you can do next is just get the sum of those lahat ng x components, get the sum of all the y components. Then after that, i-compute mo na yung resultant vector. And lastly, hindi naman mag-e-end yan dyan, you still need to compute for the degree or yung theta natin. And that theta, again, is just equal to the arctan or the tangent, the inverse of tangent of our Ry over our Rx. So that will be our superposition of forces. It is the same scenario dun sa mga pinaggagawa natin dati. Kailangan mo lang ng, tawag dito, kailangan mo lang ng mga X components and Y components mo and you'll be golden. So, for example, hirap naman itong nilagay ko dito. If you're trying to remove a car, ba't yan an car? A car stuck in mud, three, three, three horizontal ropes were used to pull the car out of the mud with corresponding vectors below. Find the resultant of these three pulls. Feeling ko dito sa ginawa niyong to masisira na yung sasakyan. But anyway, so ano ba mangyayari dito? Ganun lang. You have here three vector forces. Let's note this as F1. This is our F2. This is our F3. So you have here three forces of vectors or three vector forces. Okay? So ang sabi natin dyan, pwede kang gumawa ng table para mapadali ang buhay. Ano? Okay. So by table, you have here your F1, you have here your F2, and you have here your F3. Okay? Then get for the F1x, get for the Fx's and the Fy's. Okay? So paano gagawin 'yon? Tulad lang nung ginawa natin kanina. Ano? We just need to multiply this vector force or this magnitude to the cosine of its degree. So, para gawin yon, syempre, hindi natin basta pwedeng gawin yon. We need to get the degrees first or the direction. Kailangan kasi yung direction natin, as you may have remembered, it should be north of east, meaning to say galing siya dito sa x. So, para dito sa F2, meron na tayong 31 agad dyan. So, madali siya, ano. So, dito naman sa F1, so, kailangan kasi natin gawin mula rito sa x-axis, kailangan nating i-compute towards doon sa ating angle na yan. So, this is, as you may have remembered, this is 90 degrees north of east. So, we'll have there 90 plus 132, we'll have there 122. Similar for this angle here. So, mula rito sa x-axis, papunta rito. Ay, hindi lang dyan. X-axis, papunta rito. And as you may have remembered, this is 180 degrees. So, 180 plus 53, that will be 233. So, yan yung ating mga directions using north of east. Then, for the fx's, kailangan mo lang gawin, get that magnitude. So we have there 788 newtons. Then you just need to multiply that to the cosine. So pag x, cosine yun. Cosine of this degree, which is 122. Okay? And to do that, balik ka lang ulit sa calcu mo. So you will have 788 multiply mo lang sa 122 cosine. Okay? So that will be negative negative 417.57. Gawin na lang natin 417.6. 417.6 newtons. So that is our Fx for F1. Similar formula or similar concept yung gagamitin natin para dito sa F2. So you will have 855 newtons cosine of 31. Okay? So 985 multiply natin sa 31 cosine. Okay? So that will be 844.3 844.3 newtons. Okay? And lastly, we have here our ganun lang din. So we will have here 411 newtons cosine. Eh, ba yan? Wait lang. We'll have here cosine of, ano nga to? 233. Okay, same. So we'll have here 411 multiplied to 233 cosine. So that will be equal to negative 247.3. Okay, newtons. So same for our Fy, ganun lang din gagawin natin. So we'll have here 788 newtons of sine 122, and we will have here 985 newtons cosine 31, and we have here ano to? 411 newtons cosine of 233. Okay? So, ganun lang din yung gagawin natin. So, compute ko na lang muna. So, we'll have your 788 times 122. Then, kunin ko lang yung cosine niya. Okay? So, that will be, ba't cosine? Okay, so we'll have your 788 times 122 sine. Sine nga pala. Sine. Alright, so that will be 668.3. Okay, then we have here our 985 times 31 sine. So that will be 507.3. And lastly, we have there our 411. Nga ba cosine yung sinulat ko dyan? Sine. Nope. So we'll have here 411 times 233 sine. Okay, so we'll have here negative 238. 328. Negative. Alright, so we have here our fx and fy components. Ang kailangan na lang natin gawin if we just need to get their summations. And pag nakuha na natin yung summation of fx na yan, meron na tayong rx. So, which is our rx. Okay? So, to do that, you just need to add them. So, paano mo i-add? Siyempre, kailangan mong i-account yung negative sign. So, we have here our negative. Nope. So, that will be negative 417.6 is negative plus 844.3 plus our negative we have here our 247.3, negate that. Okay, so we'll have here 179.4, and for this one ganun lang din yung gagawin natin. So calculate lang ulit. So we have here 688.3 plus 507.3 plus ano ba plus pa? Minus na lang. Minus 328.2. Okay? So we'll have here 864 and 67.4. Okay? So correct lang natin tong iba rito class. That should not be cosine, that should be sine. And this should be sine. Okay? And we have here our Ry and our Rx. Okay? So lastly, ang kailangan nyo na lang gawin dyan ay compute yung resultant mismo. Kung ano ba yung magiging force natin. So, we just need to get the square root of the square of our Rx there plus our Ry. So, what will happen here is, sige, gawin na lang natin sa calcu. So, we'll have here 179.4. You just need to square that plus, ano to? 867.4 square. So, you have that number, okay? And you just need to get the square root of that. So, you'll have there, so let's just get the square root of that. Ayan, right? Square root of that. So, that will be 855.8. Okay? So, this will be 855.8 newtons. So, that will be our resultant. And for our degree or our theta, this will be just equal to our tangent of Ry over Rx. Okay? So hopefully naalala nyo na or the negative tangent or the inverse, the arctan of Ry over Rx. So what will happen here is we just need to get, so para safe, ang pwede nyong gawin dito class ay lagyan nyo ng parenthesis, tapos your Ry, so we'll have here 867.4 divided by 179.4. Yun ang parenthesis yan. Then, you just need to get the arctan. So, you just need to press this second function, then negative tangent. So, we have there 78.3. Right? So, meaning to say, magiging direction niya is somewhere papunta rito. Okay? At force of this will have their 800. Ang R natin will be 855.8, 78.3 degrees north of east. Okay, so that will be our resultant. That will be the resultant of our three poles. So, sa isang problem, makikita nyo, ang tagal ginawa kapag wala, lalo na kung wala kayong calculus. So, this will be one of the examples of what we call superpositions of our forces. And the next part of this lecture will be regarding Newton's law. So let me just cut the video here first kasi masyado nang mahaba yung ating video. So in that, see you in the next video. Bye!